Добрый день.
Good afternoon, my name is Konstantin Knignik and I work in Postgres Professional. The best way not to fall asleep at somebody's presentation is to present yourself, to speak yourself. And I would like to speak about my extension to Postgres VOPS that I did a year ago and why it is all needed. As known, queries to databases can be broken down into two classes, OLTP and OLAP. OLTP queries call pretty small array of data, the so-called point, select and updates, and there are many queries and many clients of this kind. With OLAP, the situation is reverse. We have a very small number of queries, but they process huge amount of data. And if Postgres shows pretty good results with processing OLTP queries, even compared with commercial programs, and yesterday we were told that Postgres won over MVCC. With the OLAP, the situation is much worse. Databases specially dedicated for analytical queries processing, like vertical hyperl, outpace Postgres by a factor of magnitude. Why does it so happen? And why is Postgres why does Postgres process OLAP queries pretty slowly? First of all, a lot of time is spent to unpack tuples. Mostly they have a lot of columns, and columns have format with a variable length. Secondly, there is query interpretation overhead. Postgres has a classical executor and optimizer comes up with a query execution plan. That is a very simple query, and in squares there are the nodes of the plan, and there is an indication for function, and the executor just calls these functions, and for every write for every transaction we need to send the function. And that all happens pretty slowly. In some databases, for example in SQLite, bytecode is used, and it has certain advantages as compared to query tree execution, but anyway, it is losing to the native code by 10 times as compared to if this query is written in C language. Now let us go back to issues. An issue with abstract types of data. Postgres is the first database that initially was conceived as expandable, like Oleg has just told us, and expandability is a very important concept in Postgres. Practically everything can be expanded in Postgres: data types, functions, operators, indexes. Heap was not expandable till today, but they would like to do it as well. But there is a problem connected with this, that any transaction, both for embedded types and any other executed types, are performed in a certain way. Executor calls a function that should compare two numbers, whether be that int number or complex number that you added. So this function call is pretty costly as compared to the ordinary instruction to compare two numbers. The fourth point here is a pull-push model. There are two types to arrange computation. Either the operator drags in the operand and performs certain actions on it, and then gives the result to the top. That is a pull model, and it meets human thinking more, and it is easier to think, ponder, write queries, and analyze in the terms of the pool model, but it has certain disadvantages in terms of performance, and there has been a lot of research that showed that around 35% can be won thanks to replacing pull model with push model. And in push model, operator does not drag in data but pushes them to the top, and operators react to what they receive, and certain actions take place. It is a bit more difficult to implement it and to understand it, but it is better in terms of using the cache of the processor, because the same data go all along the stream at the same time. And the last point includes the last point of issues includes MVCC overheads. As known, Postgres is a relational database, and for its support, every tuple has additional information on the number of version and transaction that has written it in, and around the header of the entry takes 20-something bytes, so the information is pretty large. And if you want to write some data from a sensor, some float number, and you add 20 bytes to these 4 bytes of float, it is clear that it takes 3 times more space than actually needed to you. And naturally it impacts the speed as well, because the speed, big data is determined by the quantity of data that you read from the disk. So all these issues explain why Postgres can lose up to 100 times processing OLAP queries to databases that try to circumvent these limitations. That is a typical OLAP query profile processed in Postgres, and you can see that a lot goes to slot deform tuple unpacking, and that is a function that takes a sequence of bytes on a page, tries to extract attributes out of it, and all other operators work with these unpacked attributes. 14% is computation of statements, mainly that is filtration. If there is some condition, computing whether this condition is valid or not counts for 15%. And PCH is an example here. That is one of the most well-known benchmarks for analytics. It is in charge of a system where goods flow between suppliers and consumers, and there are several tables where links between the goods are written in, and certain queries are executed that compute what is supplied from which country. So these are ordinary OLAP queries. An aggregation takes up the third, fourth, fifth, and sixth lines or places in this plan. So that is aggregation accumulation. And float 8pl is the function that I have told you about, that is for adding numbers of double type, and it is called as an ordinary function, and Postgres does not have any optimization for doubles, and work with them is done as with other types. And we also have iteration on heap at the end, and comparison of char types. So I have shown you the query execution plan already, And that is what the traditional query execution HR signature looks like. We take one attribute, another attribute, multiply them, get the result, and then we need to calculate the aggregate, and we add it, and we perform this sequence of actions for every write. How can it be accelerated? It can be done if we carry out transactions not for scalars but for vectors. For example, here we can see 3 numbers, but it is more interesting to use tiles of around 100 size. And some call it tiles, others vectors, still others somewhat different, I don't remember what, but the essence is the same. We take several values and perform a transaction on several values at once, and that gives us a chance to write this cycle of adding as an effective cycle in C language, and therefore the code is executed at a maximum possible speed, and overheads or interpretation will not disappear. So anyway, we have a standard executor, standard plan, but the executor now performs the summing transaction not per every tuple but per 100 tuples, and overhead from interpretation goes down by 100 times, and overheads for tuples unpacking goes down by 100 times as well. But that happens only if the format allows us to extract this data effectively. And talking about the format, practically all classical databases have horizontal rows, and every write has a sequence of bytes, and if we need to read something, we break down this sequence of bytes and work on them. Databases for analytics prefer vertical view of data. That is when our table is transponent and we store columns separately. Why is it better? It is better because we can extract only those columns that we need to execute this or that query. And actually, queries do not always use all the attributes that are present in the table. And it allows to decrease the number of data read from the disk. Furthermore, if we store data in columns, we can compress them more effectively, because the numbers of the same type sequentially positioned are compressed very well. And for integers, there is a good algorithm of compression, and for floating point, a good algorithm can be created as well. And there is an extension of CStore that does this. Data are stored in columns, and thanks to selectivity and thanks to reading only the data that are needed, and thanks to data compression, the speed of query execution can be increased by several times in column read when data are read from the disk. If the database is stored in memory in full, CStore does not win over standard Postgres practically at all. In the case of VOPS, VOPS, I didn't want to come up with my own storage. I had a special extension that I told you about long ago, in-memory vertical storage. There, MVCC columns are stored classically. Here the approach was somewhat different. We want to store ordinary 8 kilobytes by default Postgres pages and unravel local entries there, and this format is called Pracket, and One of the most well-known instruments in analytics is not a database, but a distributed engine to execute queries on data that are stored in some distributed data system. So the main format there is per-cat. The data are shown as tiles, and every tile is processed with their own transactions. So how can we do that? VOPS does it in 3 ways. First of all, Postgres, as I have already said, has abstract data types that allow to do a lot of things. For example, you can come up with a special type for tile to work with it just like with ordinary numbers. So instead of writing 2 plus 2, you can write tile plus tile, and then these 100 numbers will be summed with each other, and from the point of view of SQL, it will look like an ordinary query. So that is how you can define your own operators in Postgres, and VOPS float 4 is a substitute of float type that is a tile of 100 floats, and there are all transactions defined for it, all arithmetic transactions plus comparison. And using these operators we can write statements both in from list and in conditions. So we can write our column of ops flow for type is more or equals another column. But Postgres operator has certain limitations. For example, you cannot redefine logical operations and or. For them, you have to use special symbols. You cannot redefine between operator. For that, I was forced to enter my own operator betwixt, which is an outdated word in English, which means the same actually. These limitations can be circumvented using planner hooks. So Postgres created a query execution plan, and then it allows to call certain users hooks that can do something else with this plan of query execution. Add some transactions, change something, and thanks to these hooks, VOPS turns ordinary between into vector between, or logical transactions. And thanks to that, we can write queries not in this VOPS, as I say, bird language, but using the ordinary SQL syntax. But that is not enough either. If we want to use VOPS tables in ordinary SQL queries with joins, with groupings, with the CPE, this VOPS table from Postgres' point of view should look as ordinary Postgres data. So we have to transfer and turn the data back. So turn our tiles into vertical columns and horizontal rows. And that can be done with Postgres FDW, another Postgres mechanism that was created to enable work with other databases or with remote Postgres, but it can also be used to implement your table. I don't know whether there are users that have used vertical. Pretty many of you. Maybe because that is one of the most popular databases for analytics. So Vertical is one of the first commercial databases that is most successful, and it uses vertical storage, and it has such a notion as projection. That is when we store one and the same table in several ways that are optimal for these or those queries, depending on what columns we are going to sort or group data on. And the same can be done in VOPS. It is is not necessary to turn the whole table from horizontal into vertical. It can be effective to combine both. And if we know that in some fields there will be grouping, it is better to leave them in the scalar way and turn the rest into vectors. And then we will have a Postgres write with the scalar numbers and vectors that correspond to these values that grouping is done on. And let us have an example from PCH. There is a large table with fields return lag and others.
As we leave these flags as HRs, the other fields which describe the purchases are turned into vectors. And when we import data into these projections, we do groupings. All the data, all the entries that have the same return flag aligned values, all these entries are coordinated and turn into one single entry. When the entry is filled, and like I told you, the size is big, then the next entry will be generated. How is the data filled in? You can do it in VOPS. We have an existing table, a regular Postgres table with line items where we have uploaded the data in a standard way. We can export data from it. We can use the populate function. We use it to transfer the definitions to the VOPS table like this. Or we can send a link to a regular Postgres table. The function understands how to reflect the group of attributes in a different group of attributes. So the data is transferred from vertical to a vertical view with the grouping. You can also upload data right from the CSV file. We have the VOPS table, we have the CSV file, a regular Postgres format, and we take data from it, and it gets directly into VOPS. Here I'd like to note, though, that the VOPS line items table is a regular Postgres table, meaning it is stored on the disk as all others. It also goes to while, you can back it up, so all this data is in no way worse than the data in a regular Postgres table. So in this case, I'm showing you an example of how you can describe the requests in VOPS, queries in VOPS using special VOPS operators. Like I said, you cannot write usual using the usual operator between. You have to use betwixt. You cannot use and or. You have to write the commercial and. Furthermore, after the v, there's a filter function, which turns the vectorized rows into a Boolean vector into a scalar vector, which the Postgres executor can understand at a later stage. In my second example, in my second case, I would like to show you how we do aggregation. It's basically map-reduce as it is. It breaks vector data down using certain keys, and there's a certain reduce function which gathers all the data. So this approach is unfortunately not quite popular with users. I saw this from my previous extension, MCS. People don't want to learn foreign languages, even if they're just an extension of SQL. People know SQL, they don't want to use anything else other than SQL. They don't want to learn anything. So this is precisely why I was telling you about executors and Postgres FDW. How can you determine the table using Postgres FDW? It's quite simple. You have the same table line item projections where we're determined the VOPS times what columns we want to transfer. And here we set the table which we would like to get at as a result. So this function does the reverse transformation from vertical to horizontal. So this table line items can now be used in any query. It is not different in any way from in terms of Postgres. With a small nuance though, it has distributed access now, whereas Postgres, starting from version 9, supports parallel queries, and they work quite well. It's up to 10, but actually does linear scaling. Unfortunately, tables transformed using Postgres FDW don't work like this. Therefore, queries with joins for VOPS work slower than queries for the native Postgres table, just because of parallelism. Because parallelism allows making it several times more quickly. And below you see an example of how you can use this table in your query. There's nothing magic, no magic about it. It looks precisely the way a usual SQL looks. So I'm showing you two examples of queries. On the left-hand side, you see the regular SQL query. On the right-hand side, the new query. The only difference was that the lateral with data had to be shown. That is, it was the date. Otherwise, the compiler wouldn't understand how to transform this type properly. So basically, what helps us to use VOPS? The speed of TPCH request was 20 times higher. Clearly, it's not 100 times, which Hyper gives us. But consider that you don't need to change anything in the Postgres engine. This is very good. I will tell you a bit later about the alternative solution, which is now available already. But so far, nobody has reached such an accelerator. Clearly, this was an ideal query for vector. For vector implementation, because we have only vector filtration here. We have a big table with lots of attributes. We have groupings with aggregation. As a result, the result is very simple and small. It's just 4 lines. Basically, the entire huge table, all the terabytes, is reduced to just tens and dozens of bytes. So some of the solutions work very effectively here. P6 is another query, but it's more about filtration, less about aggregation. As we saw, the filtering, and this does not take so much space, so the win here is not so big. It's not about 20 times, it's just about 5 times, but still it's not so bad. So what happens with the rest of the queries? Like I said, nothing good happens to them. If the best comes to the best, the speed can be similar. In the worst case, we only lose up to 2 times. Because the regular queries are run in parallel, whereas here we lose the parallelism. What are the alternatives? Actually, there are quite a lot of alternatives. There are citrus data, which was implemented with C-Store for the first time. They also showed the results for the PCH. They showed the results which were much better with Mark Sipple, only the version was quite ancient. At the moment, Mark Sipple is much better and much quicker. But CitusDB get their results mainly owing to the distributed implementation, execution. They don't just run several instances of the database. They also shard data between the databases, and then they run the query in parallel. Q1 query is also executed very well on sharded data. Parallelism alone ensures quite good results. They did not use C-store here. But Citus also has a special vectorized extension for the C-store. They implemented vectorized calculation, but it was a diploma work of a certain students. So it is somewhere out there in the network, but nobody really uses it. Operators in this case are implemented in a different way, but this will not be used in production. Green plum. Maybe this is the best known analytics for Postgres. They claim this is the very first open source analytical solution worldwide. Basically, the idea is the same as with Citus. You just simply put data in many nodes and you run the requests in parallel. But Greenplum has a much stronger optimizer that helps to execute complicated requests with joins in a much better way and execute them in parallel in a distributed environment. Next, there's the Vitesse data company, which issues the commercial version of Postgres for analytical purposes. Actually, this is not quite Postgres. They took the free version of Greenplum and added its application to it. I will tell you in my next report about it. It's quite an interesting alternative. Vitesse claims that they have been able to go ahead of Greenplum 4.5 times just because they use liquid GID compilation. What is a GID compilation? It's an alternative approach to losing the interpretation overhead. If the native code is executed 10 times quicker, then let's generate it. In particular, if you consider that there are lots of very good to use frameworks. We made a number of attempts to add JIT Postgres. Guys from the Institute of Systemic Analysis tried using it. They had a prototype. They showed quite good results. With Q1, for instance, they could accelerate up to 5 times. With other requests, they also had a win, but only to a smaller extent. But unfortunately, they could not fit into the Postgres community. They offered a patch of 1 million lines long, and they said you're free to take it, but nobody really wanted to. Now an alternative solution is underway. The current developer made the necessary entity for it, and now slowly but surely this gentleman is trying to embed JIT into Postgres. And I'm sure that it will be embedded maybe by version 12. At the moment, the win is only twice as long. But the developer claims that it is not going to be a problem to make it even quicker, because it has not been focusing on performance so far. So what would be better, JIT or the vector operation? Basically, these are two alternative approaches. And Hyper is one of the quickest databases worldwide, as the developers claim. So the analytical database uses both approaches. They create views and generate the native code. They focus a lot on parallelism and optimizing the architecture, so that each processor works with its local memory at the highest possible speed. Vector view It helps to attain all that JIT helps. Because if we compare 100 numbers, we get this optimal code. And what we don't need to do, we don't have to use code generation. Because despite all the virtual machines, all the frameworks, it's still deportable. It's a very system-specific solution. Andreas published this patch a short time ago. The most of the comments from hackers is that some of them are not going to install it, others have, but it does not work, etc., etc. It's much easier with vector things, because here everything is written in standard C, in a regular C. So from this point of view, this approach achieves getting even more, because you can see they're offering a winner 5 times quicker. I had could accelerate 20 times quicker. You will ask me how you can do this. I will explain. So it takes a lot of resources to unpack tuples. Clearly, Andreas has. There's a JIT to do unpacking. It's one of the important components of its work. And it loses quite a lot of time from this. But still, the format remains the same. So, even despite the fact that we have replaced the cycle on GIT with a native code, still the overhead is there. In case of VOPS, we have a format where the data do not need to be unpacked. It's there, almost ready to use. You just take a look into the manual and you get a vector. As a result, what you get is not 5 times, but 20 times. Okay, where will it grow? I told you already that I wrote this all about a year ago. Then our clients used to test VOPS, and they received very good data. It's not 20 times though, but 7 times. But still, it is also very good. But we want, or rather the clients want, to reach the same without any additional, without any pain in the necks. We want to get to the tables without changing anything in the applications, or else to get a win. Alexander told us yesterday about the roadmap of Postgres, about the ability to implement in Postgres all sorts of foreign bonds, all sorts of foreign storages. I want to do such a, organize such a storage. Maybe organize it. Maybe even support the package format to be able to work with with files from Hadoop. Because Hadoop and Park are two very popular analytical tools. We also can use custom nodes, which is yet another way to affect the executor of the Postgres, to become more efficient in our operations. I have not stated it here, but there's another way, which is always used, which is always discussed in Postgres conferences. It's about using the GPU to accelerate your work. The Japanese have been working on it for quite some time. They have been making some very good progress there. So GPU helps you to unparallel queries. If we have like about 10 cores in the system, we have about several hundreds of cores in the graphical system. So if we unload this system, we can get a very good win. So what is good that they have been able to demonstrate it on join requests. They unparalleled the joins and did it very efficiently. They can do a shuffle and join very efficiently. Well, this is basically all I had to tell you about the VOPS extension. Now I'm ready to take your answers. Questions, I'm sorry. Hi, my name is Dorothy. I'm from Juna. I have this question about unparalleled operations. When you use it as a foreign data wrapper, maybe you can you can make two foreign data wrappers. One of them will do the work, the other one will do the parallel, this parameter in parallel. Well, you need to think about it, but I didn't quite understand your idea. So the foreign data wrapper is not thread safe in terms of Postgres, so you cannot use it with parallel 6-star. When the Postgres planner bumps in such a node, which is not parallel saved, it can use the parallel plan. So nothing works.
Yes, but inside the wrapper, we can use parallel scan. Yes, internally it is possible. And my first solution was based on that principle. So I took the whole for myself. So I started streams and made them parallel on my side. But here, I wanted to have minimum changes to Postgres to use Postgres infrastructure for parallel things. And it works pretty well. But with joins, regrettably, so far it doesn't happen so successfully. Hello, my name is Andrei, and my question is on the same topic. And if we do not use VDV, but your native language that works at a low level, if you use it only, will you reach parallelism in tens? Yes. Hello? Hello? My name is Alexei. Could you comment on the following? So if we have a table that the application continues aggregating data from, what we would like to have is some enable VOPS so that for application everything is transparent, so that it shouldn't know that it starts aggregating from VOPS table. So, is it doable by the same plan hooks? Well, naturally it can be done, and Postgres VDV does it now, because you write a query and you select it in VDV, but actually selection from another table takes place. Another thing is that if you want to get maximum speed, you need to create these projections on purpose that are optimized for specific queries. And for Q1 there was this projection created, and thanks to that we got this 20 times. And if you create just some generic on data wrapper without grouping the statuses and return flags, everything would have worked, but you would not have received this 20 times result. So here, like in Vertigo, we have to spend a lot of time on the design of the schema and correct data projection. Sergey Girimko is my name, and I didn't understand how to change data after we upload them there. Where are updates and delete? Changing data, the simple answer will be know-how. I forgot to mention the difference between analytical systems and OLTP. As a rule, they deal with read-only or append-only data. So all this other activity is excessive. So data are just described. In, for example, VOPS, you can add the data to the table. You cannot change them. So you have an ordinary Postgres table. You then take this data to VOPS, and you can indicate timestamp or some key on from which field to which field you would like to transfer data. But as a rule, practically always in real systems, you do not mix different things together. There is analytics and OLTP differently. Like in vertical, everybody likes it, but if you add data write by write, the speed there will be 10 TPS per second, because it is not meant for that mode of operation. It is meant for bulk update, when you accumulate it all and then you roll it out. And the same goes true with VOPS. You get data, then you transfer them together into VOPS, and then you can run analytics. I'm Sergey. What data types are now supported? As for numbers, yes, I got it. And what else? All Postgres numeric types are supported. Data time, and that's it. Text is not supported now. So you can group on it. If you have symbols, broker information, traders information symbols, you can leave it as a scalar type, like a return flag has each AR type, and then you group data on this simple open, close, high, low, date, and that is all shown in vector type, and you can calculate the mean average, moving average, analytical function, and so on and so forth. That all is calculated and computed well. And as for text, no, you cannot do it. All the types are now fixed size, so that is the limitation that exists. But generally speaking, it makes sense to take rows into a separate table in case of text, and use codifiers and integer, not to store excessive data. As for roadmap, I have already said that as soon as a strategy on a web storage plug is elaborated, I am planning to turn VOPS into pluggable storage. So it will also be an extension. It will not need any changes in Postgres core, so it will be added to the site, but it will be integrated much more, so that no tricks with videos will be needed. And then, possibly with the help of custom nodes, it would be able to implement effective parallel joins and other transactions. I also hope to support other types, so that from the users, Postgres users' perspective, they would have options. That table can be vertical or horizontal, or at the level of the fields. These fields can be vertical, these horizontal, and then do whatever you wish, so that from the point of view of SQL it is not different. Another question is about partitioning. The tables are large, and we add and add and add. How can we partition that, break that down? So whole VOPS is not connected anyhow with partitioning. It all happens within one unit, but there is nothing on the way of joining VOPS with partitioning, and there is shardman and other stuff, so that can all be united. And from the point of view of passman and shardman, this table is just an ordinary table that can be inherited, and ideally everything should work well. Hello. And if the table structure that we take data for VOPS for changes. For example, a column is deleted. Will the VOPS crash? VOPS needs the structure of the source table only at the level of import. So when you import data from one table to another, and it does not demand the strict correlation. So it takes all the fields that are needed and what else there is in the table. It is not of his business. And if some field that is needed is not in place, then it will say, well, stop. And there can be different types. For example, you can convert float 4 into float 8 and vice versa. So the answer is nothing will happen because VOPS knows nothing in the original table unless you would like to get some more data imported from it. Hello, my name is Sergey, and while adding to VOPS, if we do it during some transaction and then we roll this transaction back, will all the data be stored in VOPS anyway? Well, I have said that this VOPS table, from the perspective of Postgres, is an ordinary table, so all transactional semantics is met. And if you do populate, and then something happens at this very moment, for example, there is power interruption, or you press Ctrl-C, then the transaction is rolled back and everything in consistent state. And you use a transaction implemented in the engine, in the core of DBMS. No, that is all standard Postgres. So again, from the point of view of Postgres, this VOPS projection is an ordinary table. It just has somewhat inordinary entries. For example, some people like using JSON to have a lot of embedded entries into one entry. And here it is a similar thing, but apart from, instead of JSON, these vectors are used. But again, from the perspective of Postgres, it is an ordinary table. It has ordinary but large entries. Konstantin, one more question. Can several data sources be used? Not a table, but something different. Well, the populate function proceeds from a table, but you can create a view that will have any select and then a complex query. The data will be imported from it. Hello again, that's me. Again, I believe I misheard. Are there any capabilities of indexing title fields? For example, in this case, of the ship date, can index be created? Gene, for example? No, there is no capability of indexing this field. That is why it might make sense to come up with non-title fields and index them. Like, for example, I told you that you come up with a field of symbol. Yes, I got it. There will be a ship date for the current date, and it will have a lot of titles. Yes, like that. If you don't have any more questions, then I will be here till the end of the day, and if you have any questions, I will be happy to answer them. Thank you very much for your attention.